So if we're solving trig equations, we're solving them just like we would solve regular equations. Our ultimate goal, though, instead of getting x by itself, before that, we want to get just the trig function by itself. So it still follows our same rules, like if we have to get rid of a +2, we're going to move it to the other side by subtracting. So we're still going to use our same solving equation rules. Our first goal is to get the trig function by itself. Once we get the trig function all by itself, then we use the unit circle to figure out what the x value actually is. So if we look at number 1, it says sine of x plus 2 equals 3. I need to get sine of x all by itself. I need to move the 2 over. So I'm going to subtract it on both sides. Now, if you can subtract 2 on both sides in your head, I'm okay with you not physically writing down -2 underneath the equation. If you like that and it helps you organize your thoughts, you are more than welcome to, but I'm not looking for you guys to actually do that with every single step because it gets pretty tedious, and I understand that most of us at this point can do it without writing it, but I would just want to make sure you can see it. So when I subtract 2, they cancel, and I'm left with sine of x equals +1, right? 3 minus 2 is +1. So at this point, I only have sine of x on the left side of the equal sign. So now I want to use my unit circle to figure out when sine is 1. So I know sine is my y value. So I'm going to go around my unit circle and look for y values of 1. And I'm always going to start at 0 and just travel around looking for values of 1. And I see I have a y value of 1 here. And that's it. Nowhere else on the unit circle as I go around do I have just a 1 in the y value. So once I find that, that tells me that x has to be pi over 2 because the sine of pi over 2 is 1. So the only place that that statement is true is when x equals pi over 2. That's going to be my final answer for that question. So I use my regular solving equations rules to get the trig function all by itself, and then I use the unit circle to evaluate the trig function. Do you just want me to go to number 2, or do you want to do a different one? I don't have to. I can if you want to. Just go to number 2, so until we start feeling comfortable. Okay, so what's the first thing I'm going to do in number 2? If I've got 4 secant of x plus 8 equals 0. Subtract 8 on both sides. When I subtract 8 on both sides, I'm going to get 4 secant of x equals -8. Then, what do I want to do? I've got to get rid of that 4, right? So I got to divide by 4 on both sides. When I divide by 4 on both sides, I end up with the secant of x equals -8 over 4, which simplifies to be what? -2. So I have 2 options here. I can use my knowledge of secant and the unit circle and try and find where secant is -2 on the unit circle, or I can know that secant is the reciprocal of cosine. So I can flip my trig function here to be cosine and then look for cosine on the unit circle. Either way, you would get the correct answer. It's just more of a preference of how comfortable you feel with the unit circle. Personally, I'd rather work with sine, cosine, and tangent if I can. So I normally like to trade my reciprocal trig functions to be sine, cosine, or tangent, and then look on the unit circle. So if I know that secant is the reciprocal of cosine, that means I can literally change this to be cosine of x. And instead of being just a -2, I'm going to flip it, and it's going to be -1/2. right? Because reciprocal means flip it over. Right now it's really negative 2 over 1. I'm going to flip it to be negative 1 over 2. So now I'm really looking for where cosine is negative 1/2. So I'm really looking for where are my x values, where are my x coordinates, negative 1/2. So again, I'm going to travel around my unit circle looking at my x values for negative 1/2. And I see 2 of them. So that means my answer for number 2, which I ran out of room for, is x equals 2 pi over 3 and 4 pi over 3. Anytime you're solving one of these, if it's just one trig function that you're evaluating, like we just were evaluating cosine, we may have up to 4 answers because those coordinates appear 4 times. Any answer that you get for x, though, should have the same denominator. So you should never have a situation where you evaluated cosine and told me it was 2 pi over 3 and 5 pi over 6. Like your denominator should always match when you're evaluating one specific trig function.
There's 4 negative there's 4 negative halves. What about the ones like above the one at the bottom? The second one above that one?
This one right here?
Yeah. Why does that not count?
That does not count because that's a y coordinate.
Wait, did you use the y coordinate last time?
Yes.
First one?
Yes, I did, because remember, sine is your y coordinate and cosine is your x coordinate. So that's why, that was a good question. That's why those other negative 1/2 don't count. So anytime, remember, when I'm looking at my unit circle, my x values are cosine, my y values are sine, and my y values divided by my x values give me tangent. Want to look at the next one? Number 3. So if I'm looking at number 3, I see that I have a cosine in my function, so that tells me I'm going to be working with my x coordinates because cosine is my x coordinate. Okay, so 18 cosine of x minus 9 root 3 equals 0, which automatically panics everybody because they see that 9 root 3 in there, right? But 9 square roots of 3 is just a number. There's no variable, there's no trig function there. It's just they're leaving it as a square root of 3 instead of giving you that long giant decimal. So it's more accurate for them to write it as square root of 3. It's also a little bit more simplified just because it's not going to be a huge long decimal for you to work with. So 9 square roots of 3, just a number. If you're subtracting 9 square roots of 3, how do you move it to the other side? You just add it, right? So we're going to add it to the other side, which is going to give us 18 cosine of x equals 9 square roots of 3. Make it bigger so we can see. So now I've got to get cosine by itself. I got to get rid of that 18. I'm just going to divide it, right, because they're side by side, so the opposite of multiply, divide. I get cosine of x equals 9 root 3 over 18. Ooh, but I see 9 and 18 have common factors, right? I can reduce that to be a 1/2. So I can really say that this is just root 3 over 2, which originally that root 3 was a little bit frightening, but they put it there intentionally to give us a pretty number that was on our unit circle. So now I'm really looking for x coordinates of root 3 over 2. So x coordinates of root 3 over 2. Yep, 30 degrees or pi over 6, right? and I only want my x coordinates. So as I go around, the other one I see is 11 pi over 6. So my x values here are pi over 6 and 11 pi over 6. How do you feel about these? A little bit better now? Do you want to look at more of them, or do you want to look at the square root ones? Let's look at the square root ones. The other ones you're going to solve exactly the same way we were doing those. You're just going to, number 4, move the 1 over, divide by root 3, and then find the tangent that matches that. So let's look at if we had to use a square root in order to solve. So the first one, they're telling us, sometimes they'll write it, sometimes they won't. Most of the time they will say to us, solve the equation over the interval 0 to 2 pi. And all that means is they don't want you to keep going around the unit circle, that you don't have to list every coterminal angle. So it's just their way of saying just use the ones that show up on your unit circle. And then let's look. Okay, so if we're saying secant squared x minus 1 equals 0. The first thing we have to do is get rid of that minus 1. So we're just going to add it to the other side, right? Which is going to give us secant squared x equals 1. And now when we see secant squared x is the same thing as saying secant of x all squared. The only reason they put the squared before the x is so that you know that it's like there's 2 secants there, not that it's the x being squared. So if it was written like this, that's the same thing as saying secant of x squared. So the squared, when it's the secant that's happening twice, the squared comes before the x like that. And they just do that so that we don't always have to write the parentheses. It makes it a little bit more simplified. So if we want to get rid of the squared, we're just going to square root both sides. When we square root both sides, we get secant of x equals positive or negative 1. So remember, when you take the square root of something, you get the positive and the negative. When you're looking for the positive or the negative version of a number, this is where we're going to get those multiple answers, where we're going to end up with 4, because we can use all of the coordinates, because they can be positive or negative. So now secant is the reciprocal of cosine, right? Because it would make sense for secant and sine to go together, but obviously making sense doesn't make sense. So secant and cosine. So we're going to say, okay, this is really the same thing as cosine of x equals positive or negative, reciprocal of 1, still 1, right? So now we want to look at our unit circle and say, okay, if we're dealing with cosine, this is our x value. Where are our x values going to be positive or negative 1? And if we go back up to our unit circle, our x values are positive or negative 1 at 0 and at pi. We also know 0 is the same thing as 2 pi. So technically, anytime we write down 0 as an answer, we should also write down 2 pi as an answer. So that means if we're looking at number 7, x is going to equal 0, pi, and 2 pi. looking at the other ones that are up there, are there any other ones that you would want to go over that you don't feel super confident with? Want me to do a tangent? So let's do number 9. Okay. So the first thing we're going to do, if we've got 3 tangent squared x minus 9 equals 0, got to get rid of the minus 9. I'm going to move it to the other side. That's going to give me 3 tangent squared x equals 9. Then I've got to get rid of the 3. So I'm going to divide both sides by 3. That's going to give me tangent squared x equals 3, because 9 divided by 3 gives me 3. Then I've got to get rid of the squared. So I'm going to square root both sides. I get tangent of x equals positive or negative root 3. So this one requires a little bit more work because it's not just I spy, because tangent isn't just one of our coordinates, it's our y value divided by our x value. So we need to take our y value, divide it by our x value, and it needs to simplify to be plus or minus root 3. So if I go back, I zoom out a little bit and I go back up to my unit circle, I want, when I'm looking at these coordinates, I need to divide the coordinates and get a root 3. So automatically, I know I'm not going to use this because 0 divided by 1 is definitely not root 3. I'm not going to use 1 divided by 0 to get root 3. And I'm not going to use root 2 over 2 and root 2 over 2 because those are going to simplify to just be 1. They're the same number. So my only options here are either all of the pi over 6s or all of the pi over 3s, because both of those have a square root of 3 somewhere in their coordinate. So at this point, because I'm not super comfortable with the unit circle, I'm basically just going to guess check myself to see if it simplifies. And then as you solve these problems more and more, you'll start to recognize the pattern, because all of these numbers show up over and over and over again, that eventually it almost just becomes like second nature, where when you're looking for root 3 as a tangent, you know which one to pick. So if we have 2 options, pi over 3 or pi over 6, which one do you want to test? You have an inkling for when you're dividing y and x, so it's y over x, which one might simplify to have the root 3 in the numerator? Yeah, does one look prettier to you? Do you like the number 6 better than you like the number 3? All right, let's try to pi over 6. So my coordinates for pi over 6 are 1/2 and root 3 over 2. So I'm going to take 1/2 and divide it by root 3 over 2. And I'm just going to check to see if it ends up being root 3. So if I have 1/2 divided by root 3 over 2, I'm going to take this and keep it as 1/2. I'm going to change my big division sign here to multiplication. I'm going to flip my fraction. And then I'm going to multiply straight across, and when I do that, my 2's are going to cancel, and I'm going to get 1 over root 3. Is that what I was looking for? No. So I picked the wrong one, right? The pi over 6 was not the one I wanted. Pi over 3 was the one I wanted. If I wanted to make sure, I could check root 3 over 2 over 1/2, keep, change, flip, my 2's cancel, and I get root 3 over 1. So I want my x to be pi over 3, and any other gradient value that will give me the same result, either positive or negative. So that means I'm going to take all of my pi over 3's on my unit circle, because I can have the positive or the negative. All that's going to happen when I go to those next coordinates, the numbers stay the same, the signs just change. So I can also have 2 pi over 3, 4 pi over 3, and 5 pi over 3. And those are all my other radian values on the unit circle with a denominator of 3, or that have the same numbers in their x and y's, just different signs. But the different signs are okay because I want them to be positive and I want them to be negative. What do we think? It's the most beautiful thing you've ever learned on a Monday? I thought so.